Okay, so in the last video, you saw the different forms in this chart. If you have no idea what this is, you should probably watch the other video first. Um, and what is given immediately just from it being given in that form. So if a quadratic function is given to you in standard form, immediately you know your y-intercept. If it's given in vertex form, immediately you know your vertex, and factored form, immediately you can find your roots. Okay, so I'm going to talk about how to find these exact things. If it's given to you in standard form, for example, how do you find your vertex? Well, we went over that. So what you would have to do is you need to find your axis of symmetry first, right? Is x equals negative b over 2a. And then you would have to plug it into the function, into x. I'll just write that, into x. So I'm going to do it over here just so you can see. So if I have x equals negative b over 2a, b is 4. So it's negative 4 over 2 times a. A was 1, so a is 1. And so I have negative 4 over 2, which is negative 2. Okay, so I have x equals negative 2 as my axis of symmetry. So I plug that into y equals x squared plus 4x minus 21, which is just my function, which I have right here. And so I get y equals negative 2 squared plus 4 times negative 2 minus 21. So y equals negative 2 squared is 4, plus 4 times negative 2 is negative 8, so minus 8 minus 21. 4 minus 8 is negative 4 minus 21 is negative 25. So my vertex is going to be negative 2, negative 25. So weird. Same exact thing. So you get the same thing. Obviously, they're the same function. Remember we spoke about it. These three are equivalent. They're just in different forms. But you get the same vertex as because it's in vertex form, vertex is already given. But you can still find your vertex if it's given in standard form. Okay? If you are given, actually, let's stick with standard form for now. Okay, so we found our vertex. Okay, negative b over 2a. How do we find our intercepts? Well, you can either two ways, or it's actually no, if it's in standard form, you have two ways. You can either factor or use the quadratic formula. Now, there is another method called completing the square, which we have not done. So you're not worrying about that. So right now, all you really need to worry about is the quadratic formula or factoring. Factoring or quadratic formula. So if you factor, then you get into factored form, right? But if you use a quadratic formula, which is x equals negative b plus or minus the square root b squared minus 4ac all over 2a. I know you all miss my singing so much. Then you will find your x-intercepts. Remember, x-intercepts are written as points, roots are written as x equals, and zeros is written as x equals. So let's do it. Well, we already factored it, right? You factored it up here, and then you would just use your zero product property as we did it over here. So again, if you factor it, it's pretty easy because you just use your zero product property. Now you're in factored form, and you can go from there. Quadratic formula. You would plug everything in, and you would get x equals, and then eventually you'll get negative 7 and 3. I'm not going to do it all. And then we'll talk about min and max afterwards. Right now, let's talk about these three things. Okay, so what about if it's in vertex form? How do I find the x-intercepts if it's in vertex form? Well, you would use the square root property, which is what we learned about in the last section of lessons, right? So let me write it over here. So we have y equals x plus 2 squared. Y equals x plus 2 squared minus 25. The square root property, and keep in mind, my x-intercept is when y equals 0, and my y-intercept is when x equals 0. So here, I'm going to set this equal to 0, x plus 2 squared minus 25, and just solve. So I'm going to add 25 to this side. I get 25 equals x plus 2 squared. Take the square plus or minus square root of both sides. So I get plus or minus 5 equals x plus 2. And then I subtract 2. So I get negative 2 plus or minus 5 equals x. And then when I split, I get negative 2 plus 5 and negative 2 minus 5. Negative 2 plus 5 is 3, and negative 2 minus 5 is 7. So x equals 3, x equals negative 7. So you should get the same thing. So weird. Got the same answer. Oh my God. And I'm going to put here set. We're finding the x-intercepts, so y equals to 0. And then for in vertex form, how do we find the y-intercept? You just plug in x equals 0 and evaluate. So what I mean by that is, so again, we're at this, so you just do x equals 0. So I get y equals 0 plus 2 squared minus 25. So I get 0 plus 2, which is 2, squared minus 25. And so we get 4 minus 25, which is negative 21. So y equals negative 21, which should be the same thing. Yep, negative 21. So 0, negative 21. And lastly, if we are in factored form, what is the protocol for all of this? Now, this is probably the hardest one to work with because the only thing that this is really the most useful for is finding the roots or the x-intercepts. But can we find everything else from it? Yes. Now, if we are, now I'm going to erase all of this so I have room to write. Okay. All right, so if I have the same function, so y equals x plus 7 and then x minus 3. I found my x-intercepts, which are x equals negative 7 and x equals positive 3, meaning at negative 7 and positive 3, my function is concave up because a is positive. It looks something like this, right? Now, we spoke about the axis of symmetry is in the middle. The vertex goes through the axis of symmetry, and my x-intercepts are mirror points. This and this are mirror points, meaning the midpoint between them is going to be your axis of symmetry, right? X equals negative b over 2a, or x equals h, right? H for h and k. The midpoint between these two values is going to be your axis of symmetry, and therefore you can plug that value in and get your vertex. Or you can FOIL it out if you really want to. You can FOIL it out and then just get it from there. Or I'm showing you what it is without putting it into a different form. So what is the midpoint between negative 7 and 3? Well, how many units are between negative 7 and 3? There's 7 units here and 3 units here. 7 and 3 is 10. So that means that 5 units away from here is going to be my midpoint. So 5 units into, or -7 plus 5 is going to be -2. So x equals -2 is my axis of symmetry. And then you plug it in. So I'm going to write it here. Find midpoint between roots and then plug it in. So I'm plugging this in. I'm going to plug -2 into this. Now keep in mind when you have factored form, x plus 7 and then x minus 3, these are being multiplied together right here. So I'm plugging in -2, right? -2 plus 7 and then -2 minus 3. -2 plus 7 is 5. And then -2 minus 3 is -5. So -5 times -5 is going to be -25. So here's my x and here's my y. So my vertex is going to be -2, -25, which should be the same thing, which it is. And lastly, how do we find the y-intercept? Same concept as this. You plug in x equals 0 and evaluate. So if I plug in x equals 0 or substitute 0 in for x, I get y equals, this is plus 7 and minus 3. So if I plug in 0, I should get 0 plus 7 is 7, 0 minus 3 is -3. So I get y equals 7 times -3, not minus 3, times -3, which is -21. So I should get the same thing here, -21. And last but not least, what is the minimum or maximum value? Your minimum, and I'm going to explain this more when we do quadratic word problems to like its extent, but the minimum or maximum value is going to be the, the y value of the vertex. Of the vertex. So what is the y value of the vertex? It is, where's your vertex? -25. I can actually write this here. -25 is given here. So you have to find your vertex first. Find vertex first. Find vertex first. You have to find the vertex first. I know it's a little messy, but it's a nice little picture.